Electrical machine design, transformer design. Problem 1. Problem. Design the magnetic frame of 3-phase 250 kVA 6600 bar 400 volts 50 Hz core type distribution transformer by properly assuming the values of various design parameters with respect to the following: first core section, second diameter circumscribed circle over the core, third window area, fourth dimensions of window, flux in core and yoke section, flux density in yoke section, seventh dimensions of yoke. First assume a cruising form section. Diagram shown, transformer diagram, that is window and core and yoke sections consists of W is overall length of yoke, D is diameter, solution. Given values are 250 kVA, 6600 bar 400 volts, that is HV bar LV volts for 50 Hz frequency, core type distribution transformer. QC assume, QC form. Solution. First formula, ET is equal to K into root of Q. Q is surface quantity value. So Q is 250 bar 3. K value before classes explained in tabulation K 0.45 for cruciform transformer. ET is 0.45 into root of 250 bar 3. ET is equal to 0.45 root of 250 bar 3, that is 3-phase transformer. ET finally find out 4.1 volts. Second solution, AA formula is, that is area of the core, ET divided by 4.44 F into BM. F value is given 50 Hz. Assume BM value. Maximum flux density is 1.1 to 1.3 Tesla for distribution transformer. Before classes given. AA value is equal to 4.1 divided by 4.44 into 50 into 1.2 is equal to 0.015 meters squared. We found out. Third solution, AA, area of the core is equal to Ka into D squared. Ka is 0.56 for two-steps core or cruciform type. Before classes that given Ka values, AA is equal to Ka D square is equal to 0.56 into D square. AA is equal to 0.015 meters squared. Above we find out 0.015 is equal to 0.56 D square. From this formula we obtain D value. Small d is equal to 0.165 meter. Third solution, we derive the AW value from output equation for 3-phase transformer. Output equation of 3-phase transformer is Q is equal to 3.33 F BM del KW AWAA into 10 power minus 3 N kVA. Above equation, Q is 250 kVA, F is 50 Hz, BM is 1.2 Tesla. Assume del is 2 to 2.5 ampere per millimeter squared. And this del value, millimeter squared, we convert into meter squared is very important. That is 2 to 2.5 into 10 power 6 ampere per meter squared. KW to be find out. AW to be find out. A is 0.015 meters squared. KW formula is 10 divided by 30 plus kV of HV bindings. Given values in question 6600 bar 400. 6600 volts is HV kV for HV bindings. That is converted into kilowatts, 6.6 kilowatts. So KW is 10 divided by 30 plus 6.6. KW value we finally find out 0.27. Put above values in Q formula. Q is 3.33 F BM gel KW AWAI into 10 power minus 3 kVA for 3-phase transformer. Q value is 250. So 250 is equal to 3.33 into 50 into 1.2 into 2.2 into 10 power 6. That is 10 power 6 is converted into meter square into 0.27 into AW into 0.015 into 10 power minus 3. From this formula we find out AW value is equal to 0.126 meter square. Solutions. Fourth, dimensions of window. L divided by D minus D is 3. Assume L. From this above formula we find out L is equal to 3 into D, capital D minus G. That is capital D minus D is L by 3. AW is also AW is L into D minus D is equal to 0.126 meters square. Put D minus D is L by 3. L into L by 3 is equal to 0.126. From this above formula, L square is 0.126 into 3. From this formula, we obtain L value is 0.614 meter. Solution. Capital D minus small d is equal to L divided by 3. That is 0.2 meter. D formula is BW plus D. That is D minus D plus D. D minus D above we find out 0.2 meter. So put 0.2 plus 0.165 is equal to 0.365 meter. That is third step. Solution. Flux in core and yoke solution. Pi m flux in core. Pi m is equal to Bm into Ai. Bm value is we assume in theoretical classes given 1.2 into 0.015, that is find out Ai value. Phi m is 0.018 Weber. Sixth solution, yoke area Ay is equal to 1.11 Ay, that is 1.1 into Ai value is 0.015. We obtain Ay value is 0.0165. Seventh point, dimensions of yoke. Bm is pi m divided by Ay is equal to 0.019 divided by 0.0165. Above find out value is put in this formula. Bm is we obtain 1.09 Tesla. Capital W, that is overall length of the yoke, is equal to 2d plus 0.9d. Put record values, we find a W value 0.8785. By is equal to 0.85d, that is formula for cruciform type. 0.85 into put d value 0.165 is equal to 0.14 meter By value. Hy formula is we obtain Ay divided by By, that is important formula. Hy is, that is yoke area height. Hy is equal to 0.0165 divided by 0.14, that is Ay divided by By. We obtain 0.118 meter. Hy is 0.118 meter. We obtain. Completed.